Today we're going to begin our discussion of acids and bases, and you can find this information in sections 10.1 and 10.2 in your textbook. So first, let's just talk a little bit about the properties of acids and bases. So acids, acidus is where acid comes from, and that is the Latin for sour, and that's because things that are acidic tend to have a sour taste. So some examples of this are vinegar and citrus fruits. And you can find acids in lots of different household ingredients, household chemicals that you can come across. They can be found in fertilizers, in batteries, in your stomach acid, all kinds of places. And we looked at some of these in class as some examples. All right, so bases typically have a bitter taste. They are not sour, and they are usually slippery. So the thing to think of when you think of bases are soaps. So probably none of you had your parent put soap on your tongue for using bad language or talking back when you were a kid. But the reason that parents used to do that is because soap tastes really bitter. It tastes really awful. And so it's not really harmful to kids, but it's certainly a deterrent. Okay, and then bases can be found in a lot of things that we use on a daily basis as well. So Drano is basic. Most detergents are basic. Bleach is basic. Lye is basic. So these are all some examples of places you would find bases in your everyday life. All right, and so we in this class are only going to focus on the Bronsted Lowry definition of acids and bases. There are other definitions, but we are not going to cover them in this class. All right, and Bronsted Lowry focuses on protons. So what is a proton? So if you remember, a proton is a subatomic particle that's found in the nucleus, and we represent the proton as just H plus. And that's because a hydrogen ion, which is a hydrogen atom that has lost one electron, is only a proton. That's all that's left of it. And so that's what we see moving around when acids and bases react. I will use them interchangeably: hydrogen ion or H plus or proton. All right, so let's get to the Bronsted Lowry definition of acids and bases. So an acid is any chemical that donates an H plus or donates a proton. So an example of this is HCl. We looked at this one in class the other day. HCl plus water the HCl will donate a proton or donate an H plus, and so that will go on to the hydrogen or to the water, and make H3O plus. Okay, and then what you're left with once you take the H plus off of the HCl is just Cl minus. Okay, and this is the form that all acids are going to take when they react with water. Then H plus is going to leave the acid and form H3O plus with the water, and then you'll be left with something with a -1 charge usually. Okay, a base is the opposite. A base is something that accepts a proton. Okay, so in this case, NH3 is the base we're looking at, and it will take a proton from the water in this case, so we'll get NH4 plus. So we've now added a hydrogen and we've added a +1 charge, and OH minus. So in that case, that's the water has lost a hydrogen ion, and it has a negative charge now because it has that electron stayed with the OH. Okay, so you might notice that above, in the first example, H2O accepted a proton, it became H3O plus, and in the second example, H2O acted as, it donated a proton and acted as an acid. So water is one of those substances that can act as either an acid or as a base, and we call those substances amphoteric. All right, so if you take a look at how water can react with each other, if one water is acting as an acid and the other is acting as a base, the two water molecules together will react to make an H3O plus and an OH minus. And this happens all the time in water, just in a glass of water that you drink. Some of it is ionized into these two forms. Now, when acids and bases end up in the same reaction vessel, they'll react with each other. The acid will give its proton to the base, okay? And the result of that is always the formation of water and a salt. So, a salt is just a generic word that we use for any ionic compound. So, for example, here we have HCl, which is an acid, and NaOH, which is the base. And in this case, the H will be donated to the OH minus that's there with the Na, and you'll get H2O. And then the Na plus and the Cl minus will combine, and you'll get NaCl, which is table salt, a salt. But the salt doesn't have to be table salt, it can be any ionic compound. Okay, and we call this process neutralization because when you have an equal amount of acid and of base, you're going to end up with a substance that's got pretty close to neutral pH. All right, and we're going to get into a little bit more later what exactly pH means. Okay, and then the next thing I want to just go over quickly is that some acids and bases are strong and some are weak. And so what does that mean? So when the acid reacted, the HCl, for example, in the one we looked at, all of it gives up its proton, or gives up its H plus and makes Cl minus and H3O plus. Okay, that is called a strong acid because all of the molecule is converted to ions. In a weak acid, some of the molecule is converted to ions, but most of it stays as molecules. So if we want to represent this pictorially, you can see here in the left beaker, we have all H pluses and Cl minuses. Okay, so HCl, like I said, is strong. It all forms ions. And then over here, we have H2CO3. This is carbonic acid, and it is a weak acid. And so you can see by these circles here that a lot of it is still in the molecular form, and some of it has broken up into ions. Okay, and these ions we call electrolytes. So you've maybe heard of electrolytes in your Gatorade or your Powerade or whatever sports drink you have after practice or during practice. And electrolytes is just a fancy word for something that's dissolved in solution that has a charge. So usually the electrolytes in your energy drinks or your sports drinks are mostly sodium because that's what you lose when you sweat, and so you need to replenish that. But an electrolyte is anything that's floating around in solution that has a charge.